Well, we know how to take a quadratic function that's given to us in messed up form like f of x equals 3x squared minus 12x plus 13. And we know how to graph it by completing the square. It takes a lot of steps, but it works. We've done it before. But in this problem, we're asked to find the vertex hk and the maximum or minimum value point on the graph and find the standard form of the equation to rewrite it in the y equals a parenthesis x minus h squared plus k form. Also find the x-intercept and y-intercept, and then do the sketch. And we're going to do all of that without completing the square, so you'll see there's another way to do this type of problem. So part A, finding the vertex hk and the maximum or minimum value. We're going to compare the given function f of x equals 3x squared minus 12x plus 13 to the f of x general form equals ax squared plus bx plus c. That's a c, not a 6, a c. So a is equal to 3, b is equal to negative 12, and c is equal to 13. Then the vertex hk is given by the formula negative b over 2a, comma, f of negative b over 2a. So plug in negative b over 2 times a, and then f of negative b over 2 times a. And of course, this is where the b is equal to the negative 12 and the a is equal to 3. All right, so plug those values in and simplify, and we get, we will get 12 over 6, comma, f of 12 over 6, which simplifies to 2, comma, f of 2, which is 2, comma, now what's f of 2? Well, you acquire f of 2 by running x equals 2 through the given function 3x squared minus 12x plus 13. So we're going to have for the y-coordinate 3 parenthesis 2 squared minus 12 parenthesis 3, 2 plus 13. Evaluate that, simplify it. 2 comma 12 minus 24 plus 13, which is equal to 2 comma 1. That's our vertex. Okay, now we'll notice that a is equal to 3, which is a positive number. We're trying to figure out where our minimum or maximum point is. So since we have a positive number for the a value, because this is the same a value that you have whether you have standard form or general form. It's always the same a value. Well, that means it's positive, so we get a happy face, and that would mean that the vertex is a minimum point on the graph. It's the lowest point. So the k value, the y-coordinate of the hk, is actually f of 2, which we calculated to be equal to 1. That is our minimum value. The y-coordinate of the vertex is our minimum value. We could have just gotten it off the vertex 2, comma 1. Part B, we're going to get the standard form. Well, let's see. F of x equals a parenthesis x minus h squared plus k is the standard form, where hk is the vertex. In this case, we calculated it to be 2 comma 1, and the a value is the same a value given to us, so it's 3, and we just plug those values in to get the standard form f of x equals 3 parenthesis x minus 2 squared plus the k plus 1 at the end. Okay? Now, part C, the x-intercept is acquired by letting y equals 0, of course. Plug that into either any of the equations, any form that we have here. I'll put it in the place of this equation we have for part B. 0 equals 3 times x minus 2 squared plus 1. Okay, isolate the x term that's squared, and then take plus or minus the square root of both sides. You'll get x minus 2 equals plus or minus the square root of negative 1/3. The square root of a negative number is not real. You can stop right there. Because it's not real, there is no x-intercept. We don't graph imaginary numbers on the real axis. There is no x-intercept. If we had started the graph at this point, we would have seen that there's no way it would have an x-intercept. You'll see in a moment what I'm talking about. For the y-intercept, you take the equation and let x equals 0. You'll get y equals 3 parenthesis 0 minus 2 parenthesis squared plus 1. Okay, and that's equal to 3 times 4 plus 1, which is 13. So when x is 0, y is 13. Therefore, our y-intercept is the ordered pair 0, comma 13. Now we can take all this information and draw the graph, our y-axis and our x-axis. And let's see, we're crossing the y-axis at 13, and we're never crossing the x-axis, but the vertex is located at the ordered pair 2, 1, so we'll graph that point and have that little dotted line for the axis of symmetry that cuts it in half and form our happy face parabola. That is a picture of the quadratic function f of x equals 3x squared minus 12x plus 13. So you see, you have another method that you can use for graphing a function, quadratic function that's given to you in messed up form without having to complete the square.